and then I want it to end up being d minus 1. Also think about if I took a degree d minus 1 polynomial and divided it by a degree 1 polynomial, do the division, just think about it, you're going to end up with something 1 less than this, meaning that this will have degree d minus 2, and that's important to keep track of. So what do we have now? Remember our original setup here? This is going to be important. Remember, we want to incorporate all of the factors. We want to factor it out. Well, we got the first factor, and then we had this other polynomial. But now we have what that polynomial is in terms of x minus r2, which is the second factor. So we are going to rewrite p of x, and this is the big aha moment. P of x, so I would say p of x is equivalent to, remember we have our first factor, x minus r1. And then we multiplied, we said it's x minus r1 times this other polynomial, but we just wrote down what that polynomial is. p1 of x is x minus r2 times p2 of x. Okay. And remind yourself, this is degree d. This has degree 1, so what must the degree of p2 be? It must be d minus 2. That's the degree of d minus 2, because I multiply these two together, I get degree 2, and then when I multiply these together, I'm going to get d minus 2, but multiply it by these two polynomials of degree 1 each is going to get me back to degree d. Okay? Alright, now I can guess that at this point you're saying, good Lord, how many times are we going to have to do this until we're done? And the good news is we're looking at a lot of repeated reasoning here. And just to prove that we're doing the same thing over and over again, what I want you to do at this point is I want you to now go ahead and plug in the next root. Okay, so plug in R3, because remember, we'd like to find another factor. Where is the next factor? Well, the next factor should be x minus R3. Where are we going to get that from? Well, it can't come from here or here. So it's got to come from P2 of x. So if you plug in R3, I want you to do that, you'll notice this nor this can be 0. So what you're left with is that P2 of R3 has got to equal 0. So you have a root of P2, and you can do this process over again. What I'm going to do, and so you're going to pause and do that now. Alright, hopefully that worked out for you. What we're going to do now is we're going to move on and we're going to skip ahead. We're going to skip ahead all the way to the dr of d minus 1, the third to last root. Okay? So what we've got so far, right? Let's just realize what we've got at this point. So we continue going on, and what I have up till now, I've moved all the way to the d minus 1 root. So I have p of x, and what I want to have now is I want to have everything, all the factors up to the r to the d minus 1. So I have x minus r1 all the way up till x minus r sub d minus 1. Okay. So let's think about what is the polynomial that we're going to be left over with. Okay, what is this polynomial? And what we've got to realize is, look at our degrees again. So this has degree d. Each of these factors has degree 1. How many of these factors are there? Well, there's d minus 1 of them. Right? So now, just think to yourself, okay, if these factors all end up being degree d minus 1, Well, what does the remaining polynomial have to be degree of? In other words, think about what would happen if you took a degree d polynomial and divided it by a degree d minus 1. If you took all these factors, multiplied them together, you'd get a d minus 1 polynomial. There's d minus 1 of these factors. I would be left with, well, d divided by d minus 1. I just have to multiply a d minus 1 polynomial by one more x term, by a polynomial of degree 1. So this polynomial, which is going to be p, and think carefully. So what I want you to do is I want you to pause and think about what's the number, what is this p sub what? It's got to be p sub d minus 1 of x, and this has degree 1. This is pretty important. How many factors should we expect to have? How many more? Look back at our roots, right? How many factors are we hoping to have? At most, d distinct roots. So it's okay if we have one more, right? Where is that going to come from? It's got to come from this last polynomial here. So we're going to input, p of r sub d, which is we're hoping our last root. Well, that's going to give us r sub d minus r sub 1 times r sub d minus r sub d minus 1 times p of d sub p sub d minus 1 of r sub d. Okay? And what do we know about this? Well, we know that this has to equal 0 because r sub d is a root, right? We're assuming we have all of these roots. Can this be 0? Absolutely not. Can any of these factors be 0? No, because all of these r sub whatever are different numbers. So, by similar reasoning, and we can say that because people can go back and look at our reasoning, by similar reasoning, p sub d minus 1 of x, I'm sorry, not of x, p sub d minus 1 of rd has got to be equal to 0, right? None of these can be 0, and it all has to multiply together to equal 0, so this has to be 0. So, by part C, apply part C again. If we plug in r sub d into my polynomial p sub d minus 1, and we get 0, and that means that r sub d must be a root of p sub d minus 1. And there's a lot to keep track of. P sub d minus 1 of x, that means p sub d minus 1 must have a factor which is x minus r sub d. And it must go in evenly, right? So it must be multiplied by some other polynomial. We'll call this p sub d of x. And here's the big thing that we notice. What is the degree of p sub d of x? Well, let's think about it. What was the degree of p sub d minus 1 of x? It was 1, right? It was just a polynomial of degree 1. Well, what's the degree of this polynomial? It is also 1. So what must be the degree of this polynomial? It's not too hard to see. If you have degree 1 divided by degree 1, all you're left with is the coefficient. Let me give you a quick off to the side so that we can see what we mean by this. Let's take a degree 1 polynomial. Let's call it 3x. And let's divide it by another degree 1 polynomial. Call it x. It will go in 3 times. Right? And this is a degree 0 polynomial. We're just left with the coefficient, which means that the only thing we can have left over, the only thing we can multiply this by, is a coefficient. This is a 0 degree polynomial. In other words, it's just a coefficient, right? This could be, I'm going to draw it off to the side here, this could be some coefficient, a sub d, times x to the 0th power. And x to the 0th power is 1. So all we are left with is this coefficient. And in fact, we're going to just leave it as a coefficient. So p sub d minus 1 of x is equal to x minus r sub d times some coefficient. We're just going to call it a sub d. Because in fact, that's just the coefficient we're left with. It is our leading coefficient. And this is really important because now that we know p sub d minus 1, we can plug this back in. And we're going to end up with the factor that we wanted. Alright, so we're going to have to start out on a new page, but that's okay. So we're going to rewrite, you have your notes in front of you, p of x. Well, remember, we have x minus r sub 1, our first factor, and we go all the way out until x minus r sub d minus 1, and we had our polynomial, p sub d minus 1, and we just found out what it is. So you go back to your notes and you look, it's x minus r sub d times a sub d, our coefficient, right? Because the polynomial that we multiply it by, when we divide it in evenly, is just a coefficient. It's a 0 degree polynomial. Remember, this is a 0 degree polynomial. So now we're on to the last step. Remember, we assumed that we didn't stop, our roots didn't stop at d, right? We didn't stop till we hit d plus 1. So lastly, p of r sub d plus 1. What is that? Remember, if this is a root, when we plug it in, we should get what? This should equal 0, right? P of r sub d plus 1 is 0. So let's see what we get. Well, we're going to get r sub d plus 1 minus r sub 1. We're going to, in fact, plug that into every single factor. We're going to plug it in all the way until we get to the last one. R sub d plus 1 minus r sub d. And we have this coefficient. Now think about the coefficient. Can we plug this number into a coefficient? No, you cannot. So think about what we've written here. We've written an expression, this right here, which is equal to 0. And all this expression is multiplication after multiplication. If we're multiplying things and it equals 0, what do we know about at least one of these things? It must equal 0. Well, can you find something that equals 0? Could this equal 0? Could this equal 0? Can this equal 0? So let's think about what we know. Since r sub d plus 1 minus r sub 1, can that equal 0? No, it can't. They're different numbers. Can't equal 0. And we're going to write all the way through that. We could do that for every single factor all the way until d plus 1 minus r sub d can't equal 0. We are left with a sub d equaling 0. That's the only thing in our entire thing that we haven't quite talked about, right? We know all of these can't be 0. But what would it mean if our coefficient, our leading coefficient, is 0? If you go back to the very first day when we talked about this, when we wrote our original polynomial, Remember this leading coefficient?